All right. Hi, everyone, and good morning, and welcome to the online event. My name is Mohan Ram, and I lead field marketing at Brain Trust. Today's session is on evals for real-world voice agents. In today's session, we will discuss how Navan's voice agent calls hotels, speaks with real humans at the front desk, and handles complex workflows from form filling to multilingual support. Our speakers will share with you practical steps to build, measure, and scale voice agents with consistency and quality in production. We're joined by Sarab Bhatia, Senior Director of Software Engineering, and Alfred Gao, Senior Software Engineer at Navan. They will spend the first 30 minutes on how Navan runs evals for its AI voice agent to solve the last mile challenges for travelers and finance teams. We will then open it up for Q&A. This session will be recorded and shared with all the registered participants. And with that, over to you, Sarab and Alfred.
Awesome. Hey, thanks, Mohan, for giving us this opportunity to present on how Navan's been using our brain trust and our experience building evals for voice agents. So hopefully everyone can hear me. So when I started out on this journey of building AI, what was very clear was that the entire software development lifecycle was going to be very different. And I kind of equated it to sort of building a new factory floor. So traditional methods of how we do CI/CD, or even how we sort of think about building code, a lot of those concepts were changing. And so this journey that I set on with Alfred and the rest of the team was sort of conceptualizing the new software factory floor. And that's kind of like some of the items that we're going to be covering today. Before I go too deep into evals, I wanted to kind of give you all a quick introduction on what Navan is so that you all have some context on the sort of problem that we were trying to solve. So first of all, Navan is an all-in-one travel and expense management platform. We think of us as someone that tries to make travel easy for each and every frequent traveler. Our job is, and our mission is to ensure that any traveler or any company that wants to have a TNE program has the best category of service for those travelers that are traveling on business. What our vision from my team's point of view, and what I try to work on a day-to-day basis, is basically to make sure that when a traveler or an employee of a particular company is using their cards to whether to book travel or to pay for a team expense, or even do any kind of procurement, from the time the card is swiped to the time we close the books in a traditional ERP system, all of that happens with zero effort. And traditionally, this has been an area that has been very complex and full of a lot of manual labor and a lot of manual effort that's been required. And that's what our mission has been, to sort of make it a zero effort game. So just kind of give you a sort of a little bit of a detailed use case on what we try to focus in at Navan. From the time that you go ahead and do a search and start to look at booking for travel, we want to make sure that all of those details are automatically put together in terms of expense reports, receipts, invoices, and even the fact that the card that is being used is being spun up specially for that trip, for that travel, so that we are able to track everything related to that particular booking that you have done, associated with that particular one card that was just created for you. And we call that Navan Travel Payments internally. Basically, that's how we go ahead and streamline, ensuring that every travel that happens, there is a way in which we are able to reconcile all of that into the accounting system. When we do this, there are some very unique challenges that come along, especially when it relates to hotels. Because we want to ensure that everything is tracked, there is a lot of like integration that happens with various kind of suppliers in our travel ecosystem. So if you're going ahead and booking a United flight as an example, Navan has special integrations built with United. so that every time you do that booking or you do a change or you add baggage or you do a seat change associated with it, that one card we are going ahead and tracking everything that's happening and integrating with United so that when it comes down to your expenses and your reconciliation, we have a really good idea on what exactly happened for that flight booking that you just made. But hotels have a very unique challenge because hotels have a very long tail of suppliers that exist in the world. Like maybe you want to go to Paris and you want to stay in this very unique like bed and breakfast. And Navan has a great, supply of hotels. So we want to make sure that that supply is available for you. But that bed and breakfast may not be available through an API to be able to ensure that the card that we want to use to be able to pay for that hotel can be easily sent out and paid for. So we have to come up with some very unique methods to be able to provide that card that we want to use for the hotel to the supplier, so that when you come in and check in at the hotel, that card is available to the front desk to be able to get processed. So because of this lack of like last mile challenges on being able to integrate with millions of hotels that exist all around the world, we've had to come up with a unique methodology of being able to communicate with hotels. And that is the ability to communicate by calling them ahead of time when the traveler actually arrives. Now, for us to do this at scale, we could not have gone ahead and hired like hundreds and thousands of agents to be able to do the calling on behalf of travelers. We wanted to solve this challenge with the help of AI, and that's where our voice agent came into be. So, as I move to the next slide, what I want to show you is what our AI agent called Miles does when a booking happens ahead of time, going ahead and calling a front desk agent. And this is one call that our agent made.
Thank you for calling Modern House. This is Christy. How can I assist you?
Hi, I'm calling to confirm an upcoming reservation. Can you help me with that?
What's your arrival day?
It's April 1st.
Okay, give me one moment. Oh, April Fool's Day.
Yeah.
I'm like, are you joking with me? Okay, April 1st. What's your last name?
The last name is Habeker, Habeger.
I have here that you are in a modern queen room for 4 nights, departing on Saturday the 5th. I also see that we received a credit card authorization form from Circle Company that we can use that for room and tax, so you will only need to present a card for the incidental hold of $150 per night.
Oh, got it. Thanks for clarifying that. I just wanted to confirm, the last 4 digits of the card on file are 4313. Great, that's all I needed. I really appreciate your help. Thanks again and have a great day.
You too.
Awesome. I hope you were able to hear that call. Usually in a live audience, when I'm playing that call, I know a lot of people burst out into laughter, and I now I can't hear you guys, but hopefully you had a chuckle with that call as well. So when we started to build this AI agent, very quickly, what started happening was that hundreds of calls started happening on behalf of our travelers as we were kind of doing a limited a rollout. And what became very clear was that the development team, the ops team, right, could not hear every call to be able to learn and understand how well those calls are going. What is it that the front desk traveler is asking of the AI agent? Are there failures? What kind of failures there are? And also, as we're improving the AI agent, how do we really track how well the AI agent is improving? And this is where sort of we started partnering with Brain Trust and started bringing Brain Trust to kind of create that eval for this voice agent that we developed, so that we're able to supervise thousands of daily calls happening and actually have a system in place where we're able to prevent regression. We're having a continuous improvement loop, and actually sort of like going from like this discrete, predictable software development lifecycle that we are used to sort of like a more continuously dynamic software development lifecycle. And now I want to kind of invite Alfred to sort of talk about like how he went ahead and created that detail of how evals need to work for the voice agent. I'm going to stop sharing, Alfred, and you can share. Yeah.
Sounds good. Yeah, thanks, Tara, for the intro. And hi, everyone. This is Alfred. I'm the senior engineer from Navan Commons team. So I will take you guys into the behind the scenes, how we building the eval systems into a continuous loop. And let me start sharing my screen. Yeah. So, okay. So let's start with another production called Clips.
Unfortunately, for security purposes, we do not verify the numbers on the card. They're actually X'd out, but I can verify the expiration date on the card if you would like.
Got it. No worries. Thanks for letting me know. I think that covers everything. I really appreciate your help.
My pleasure. You have a great night. This was a very interesting call. I've never taken one of these.
Yeah, so this is the one of the interesting calls like that guy have ever taken one of this. And also like most interesting for us is once we achieve that moment, the most of work actually is not about the coding itself. It's about the eval. It's actually about how we do the eval our applications, how we do our observation, and how we iterate. So let's take a look about, so echo to Sarah's points, let's take a look about how the difference between the traditional software development cycle versus the modern AI application. So for the traditional software, we're starting with such as PRD or codings, and we test it, we deploy, we monitors, and then boom, send out the Slack message for the GA for the launch. And how about the AI apps? Probably like we start from the PRD again, but instead of that, like we're doing web codings, but actually most of the work happening within this loop. So it's very easy, like we finish the coding task or implementation, but actually this loop is where the actual efforts can happen. So let's move to the slides to see how we integrate brain trust into our lifecycle. We're building our mouse agent with this mental mode. We try to push the production as quick as possible, but we want to collect the real feedback as well. So the brain trust empowers the purple circle for all of those. Starting from the static list evals, we do a couple of the offline experiments to make sure our agents behavior as expected, and we ship to the users. We ship to the user as soon as possible, and the whole point is we need to collect the real user feedback to make sure all of the AI application is work as expected. So we have the real-time monitors, we collect the feedback, we understanding how the user behavior and how the data is distributions, and then we come up with the more evals and then one continuous loop. And this is where the brain trust empowers us. So this one, I'm giving a very high-level structure how we do this looping with our voice agent. So for our voice agents, we actually having a very basic starting point. We label. So we label our voice call according to a script, and just like it is a call script we collected from our first trial of the production call, and it's give us a very high-level structure how we can evaluate the performance. And the second part is the lesson. And this one is actually where the human efforts happen. So we, and also like our teams, we mainly listen the first 200 calls to understand how the user data is distributed. So after we have a high level buckets, and we turn into the raw audio file into the GPT audio model, so this can help us tag at scale. And after that, we still keep some of the minimum human efforts in order to make sure we cover the long tail case and the long tail distribution. So we keep this loop spinning. So every batch of the production call give us the real-time feedback, like how the data distributions, and then we'll be able to adjust our evals accordingly, and which any batch of the production call can improve our system. So, and also I can quickly share you guys. So this one is so we instrument every production call, like from our mouse, which is the voice agent, into the brain trust. And brain trust right now is acting as the all-in-one centralized for our LM ops platform. So we log every call into the brain trust. So here is an all-in-one place where we can easily see what's happening in the production. So for every call, we instrument how the agent is behavior, how the agent is reasoning, as well as the intermediate steps, intermediate data, and also like come up with the eval. So let me share again. So in order to make the whole thing work, the most important thing is we need to make sure our eval give us the most accurate results. So that being said, we need to evaluate our eval as well. And I would like to take you guys take a look into how we achieve this. So we're starting from the production data. From the brain trust, we have the real production calls. So we collect the real production calls through the brain trust and we do the data cleaning. We split our production data into the training set and testing set. And then we treat the eval as a model. So we mapping the eval as a classic machine learning classifier. And our eval prompt actually right now is acting as a classifier model. So we optimize the performance using the F1 score, and we adjust from the reasoning steps. And the second thing is, remember, your user behavior can be drift, and the data can be drift as well. So we need to tuning and updating our eval frequently. So after all of those steps, so we can see we achieved a very significant improvement from our F1 score on our validation data set. So we improved the F1 score from 0.56 to 0.89. So for here, we can quickly show you guys, after we tuning this, we can see the improvements on our eval performance based on our validation data set. But one point here is the metric itself does not give us the information where the eval make the mistake. So how we achieve that? We try the chain of thought plus the reasoning model for our multi-step eval prompt. And for here, as you guys can see, we're adding the chain of thought into the prompt and to make sure the reasoning model follows the human behavior where we manually listen the call. And not sure if you guys remember the previous loop I'm mentioning about. So where the manual efforts happens here, because at the very beginnings, we manually listen the first 200 calls to have a high-level buckets where the call is distributed into the failure or success or any of the subcategory results. So the chain of thought here actually mimics what the human is doing. And also like we log every large language model reasoning steps for debug into the brain trust directly as well. So here, shout out to the brain trust team because it gave us a very intuitive and very easy UI to know like where the mistake happened. So we can quickly take a look at this example. The final choice of our LLM says the call is success, but actually is a false positive. The actual result should be false. And where is the root cause? The root cause actually happens in the first step, the sanity check. So the sanity check says the system output is not empty, so it passes sanity check. But truth is not. The system output is actually empty. So by logging the LLM's reasoning steps, we can easily debug and triage where the bug coming from for our LLM as judge. So we can easily tuning our prompt. So after we adding the chain of thought to our prompt, this version is actually the first one to achieve over 0.9 F1 score across all of the control groups. So it can give us a significant improvement on our eval performance as well. For here, I prepared this very concise and simple the summary for you guys. So on the left hand for the simple eval task, such as if it's a very simple like the fact check or just like true and false, we believe like a standard model is powerful enough. So it can give you guys the very cheap, very fast, and also deterministic results. But if you guys want to handle the complex eval task, such as the example for our voice agents, because we need a multi-step reasoning, we need our context change, and we need the model to reasoning. So the reasoning model is worth a try. So in the example, like we just actually try the GPT-01 plus the chain of thought to achieve the best performance we have. But remember that everything comes with the cost. The reasoning model like usually is very slower, it costs more, but give you the more explainable reasoning. So in summary, one sentence is, so try chain of thought plus the reasoning model when the reasoning depth matters more than the latency or the cost for your AI tasks. So actually, so all of the above is how we achieve the eval task and our best practice so far collected. So also what is the next step? Because we saw the voice AI is a little different with the traditional because voice AI equals to chat plus sound. As far as right now, so all of the things that are happening after the call is finished. And so right now, what we are working on is we want to bring the real production data into our eval pipeline as well. So for here, we want to replace what is actually happening in the production. And after that, we're just running the eval directly on that. So so by doing that, we'll be able to quickly switch the model to see what is the performance before and after. And also we can see how the eval is doing from end to end. So the summary. The first one, for most of the AI application, the coding is the most easy way. But the eval and iterations actually drive the progress. Keep in mind, for the AI task, try to keep your data feedback loop tight as much as possible. Actually, deploying to production is another starting point for all of the application where the real efforts and work happening after that. And also keep remember to eval your eval. If your eval cannot give you the most accurate results, I don't think the whole loop will gonna work. So that is the key point. Also, for the complex eval task, trying the chain of thought plus reasoning model, which can give you the better performance if the performance is the highest priority compared to the latency and the cost. Okay, so all of the above is actually our best practice when we apply the evals for the mouse voice agent. And I will hand over to Saraf for the ending part.
Yeah. Thanks, Alfred. That was super cool to get into the details with everyone. So I think I kind of want to just sort of talk a little bit about how we're thinking about it, what's next, and then of course, like Mohan said, we'll open it up to questions. So I kind of really think of EDD as the new TDD. So eval-driven development is something that we've been pioneering inside Navan and our organization in general. And I think that's how, if you're into AI driven, AI development, I think that's how everyone should be thinking about building AI. Like the way in which you build good AI agents is thinking from an eval driven development lens. So any projects that we take up, right? One of the things we definitely do is the first thing is trying to identify what is the eval set. It's very easy to sort of go ahead and create AI agents. It's very easy to sort of integrate with the OpenAI SDK or Google ADK, etc. We internally use a combination of Google ADK, LangGraph, and OpenAI. But any of these tools, you need to be extremely sure on how is it that you want to test for success. How is it that you want to make sure that your continuous loop is operating? Because unlike traditional software, um, AI software can sort of take you into various sort of branches, right? And having a good eval strategy will help you make sure that you're continuously improving and you have a loop to ensure that your agents are actually behaving the way in which you expect them to behave. So that's kind of my final closing thoughts, and we'll open it up for questions.
Sarab, there is one question in the Q&A. The question is from Ashish. The question is, can you elaborate on the classifier you mentioned in the eval? Are there multiple classifiers, and did you aggregate that into a composite score across all classifiers? What was the trade-off between considering a composite score versus each classifier score?
Yep. So if I can help to answer that questions, and also I can back to that page of the slides. But yeah, thanks for reading that. It's actually a great question. So why the reason we treat the eval as the classifier is because of the task we have right now for the voice agent. So the eval task for voice agent is we want the eval to let us know the final results for a specific call. So I can quickly show here. So we are using the eval to help us tagging the call. So we can have a high level like how the production is going. So first, we need to know whether the call is success. Success means the task is set, whether the hotel representative is able to acknowledge the user gonna be late check-ins, whether the task is complete, and if it's failure, what is the sub results? It is due to like the bot cannot pass the IVR system, or we need the manual efforts, or if like the agent just disconnected. So that's why we mapping the eval as a classifier is because of our specialties for the task itself. It's a multi-classification task. And the reason why we're doing that is we need to know what's happening to production. And after we collecting the results, we need to tune our system accordingly. Such as if we find out like one check-in is causing the surge for the agent disconnect, probably some regression. Or we find out like one model of the ChatGPT 5 cannot pass in IVR, we need to fix that accordingly. So that's the high level why we treat that. And for the F1 score you mentioned here, so basically we are using that one to measure the performance for the classifier itself. We do make sure like the classifier like doing its own job, and if there's anything wrong, we can adjust accordingly. And I hope that answers the question.
Great. Thanks, Alfred. The next question is, how did you come up with that F1 score range?
So basically, like on the very high level, like we just want to make sure like the classifier, I mean, the higher F1 score we have, the better performance the classifier will be. So that's basically the the overall mental mode behind this assumption. So we want to make sure the classifier works best on the data set while it does not like have any of the overfit. So we do have the validation data set on it. So we don't want to make sure the classifier overfit the testing data, but while it's just like messed up in the production data. So we do think about the generics in the eval as well. So that being said, we need to make sure the classifier works robust on the testing as well as the validation data set. But that's on the high level, like how we're mapping this problem.
The next question is, after your eval system matures, do you still have human in the loop for eval?
That's a great question. And the answer is yes, but very minimal. The reason is for here, so there's actually one tag is called unknown. And also the human efforts here is we need to make sure the human efforts in order to cover the long tail case, because you cannot, the production behavior can be unexpected. Anything could happen. So for the very long tail case, we still need a minimum user, the human efforts to cover that. So after the human collect the signals, we are just enrich our eval prompt and also the eval system to make sure the human efforts is decreasing.
There's one more thing I will add, and this is why I'm a big fan of BrainTrust tool. So there are things that we need people to sort of look at after the call has been evaluated for follow-ups. So, like our ops team. So, like many a cases, what happens is like our agent goes and makes a call, and what we hear from the hotel is, "Hey, great, I can accept this credit card, but I'd love it if can fill it through a payment link." And in that case, we need some manual follow-up from our payment ops team. So what we've done is the evaluation portal that we have with BrainTrust. We have a dashboard there that's kind of filtered to any kind of follow-up that is needed by a human. So the ops team basically just goes ahead and processes the data that the eval has been categorized as a human follow-up for.
The next question is, do you use LLM or traditional ML to classify the result?
For the results itself, we are just using the LLM. Actually, to be more specific, for the use case here, we are using the GPT audio file. the GPT audio model directly. So we passing the raw audio file directly into the model, and the model generates the classified results using the prompt we have.
Great. Thanks, Alfred. The next question is, do you train or iterate the classifier on the training data offline and then run in testing data in production?
That's a great question. So also like to be more specific, all of the updating part is happening offline. So also like I can reveal one of the page here. We're following the loop on this. So we're collecting the production data periodically, such as like bi-weekly or monthly. And we just like trying to make sure we capture the latest user behavior or distribution for the production behavior. And we split starting from that, we split the production data into the training, testing, and validation data set, and we updating offline. So back to the question, all of those happening offline. And after that, we're just deploying our evals to the productions and also like doing the evaluates through the production of the observation.
Great. The next question is, do you convert the voice call to transcript, then run the classifier on text? How do you handle the errors from transcript?
Yeah, that's a great question. And actually, like our very first version did try this approach. We first using the speech to text method, we convert the speech to the transcript, and we running the eval based on the transcript. And as you mentioned, we quickly fall into the problem like how we solving the hallucination when the translation happens. So later on, we just change that way. As I mentioned previously, we directly pass the raw audio file into the GPT audio model in order to prevent that. So we are not using transcript anymore. We're just directly using the raw audio file.
Yeah. I think the next thing I'd also say is it doesn't end just at evaluating the overall call. What's next for us is also making sure that when we run the online evals, as we are about to ship any new changes, we are now creating in our overall factory floor the ability for our voice agent to be able to talk with another voice agent that behaves as a front desk agent, so that we are not just depending on transcripts to be able to run our evals before we decide something is good enough of a change to be able to ship into production.
Yeah, totally agree. And also, like one thing I want to add is for the raw audio file, one advantage we observe is the model is able to tell the noise difference, which the script cannot be. So such as for the semantic difference, and also like we can tell if the hotel representative is applied or it has the very decent reply, which the audio model can tell as well.
The next question is, do you need to eval the tool usage? Audio file doesn't have that info.
Right now, we don't use tools as part of our AI agent. We will probably get to it pretty soon. But right now, when we create the AI agent, most of the context required for the agent to be able to do its job is already provided to it. So not yet. We're not doing tool usage yet with the voice agent.
Yeah, exactly. So right now we are more focusing on the end-to-end task completion, which is our highest priority KPI.
Great. Thank you. What is the next question is, what is your grader? What is defined as success?
That's a great question. So we define the success into our prompt. So I wish I could share the prompt with you guys. But so basically, like for the prompt, we have a very specific criteria. What is a success? So given the high-level example for the hotel late check-in, we tell the model like if the agent is able to specifically tell the hotel representative the booking ID, the booking information, and hotel representative is able to confirm they are aware of the user late checking and can keep the booking. And that criteria, once all of criteria are met, it can count into the success task. But overall, we just like give the detailed criteria and instruction into the prompt.
The next question is, are you using a rubric for classification? Can you frame up what a good rubric should look like in a use case like Navan?
Yeah, so basically, like we do have, because so definitely for the eval prompt, you need to tune in the prompt as well. So for the rubrics itself, so as I mentioned previously, so first thing first, you need to give the detailed instruction how the good behavior should be, and give the model one example. And also, like if you are using the reasoning model, keep in mind to try the chain of thought, so the model can also reason itself.
Yeah, and I don't know if everything fits in very neatly in a new rubric either. Um, like success is, I like I think a lot of it is sort of even like, of course, task completion, etc., is important, tone is important, etc. But like also like the output of the call can be something for also, improving your business process. Like maybe there are certain hotels that don't accept virtual cards as an example, and we want to make sure that we're able to classify those things properly into like, I would say like success codes or failure codes. Um, and then we use that to be able to improve. So I mean, my point being that I don't think like I think there's various ways to be able to classify these calls, and one has to be a little open about it, especially with AI models.
Agree. There was a follow-up for the grader question. You give example for hotel late check-in. Do you have to first have a classifier for user's intent, then define criteria for each intent?
So currently we don't have that. But basically, like as I mentioned previously, right now we're just evaluating the call from end to end. So we giving the model the whole instruction how to evaluate the test success, and we have a data set to evaluating the prompt as well. So that's how we make sure like the prompt is working as expected.
Got it. The next question was, is there any pushback or odd moments from humans talking to your agents? Like when they know it's not a human, do they wonder if it's a scam?
It
Uh,
happens
yeah.
where they it happens a lot where, they'll think it's AI. I mean, one of the things we do is we're like very open about the fact if someone asks, are you AI? Yeah, we absolutely say we are AI. We also, let them know that we're recording the call, which is sort of very standard behavior even when sort of human agents are calling ahead of time. Um, I I think like I would say like the biggest way in which that the front desk agents have sort of stopped asking us, are you AI or not, is sort of the improvements we've done in terms of being able to understand the flow of the conversation and being able to sort of adapt to that flow of the conversation. So, I mean, like I'll give you a few examples, right? Like one being things like just the fact in which, the way the start of the conversation is, right? Like when, how do you sort of do that initial, hello, the kind of latency that you have in that initial, hello. Like, we've done a lot of like fine tuning to make sure that that's like the perfect way of starting the conversation. And I think like a lot of it is also the way in which we've given like the personality and the nature to the agent. Like we did a lot of iteration on like making the AI sort of be a little bit nervous, right? Because like the first things we saw was that the AI was so confident that, the front desk agent was like, wait a minute, I'm definitely talking to a machine right now, right? So like mixing in that right level of uncertainty, right, into into the voice agent's voice definitely helped us kind of like make sure that, when an actual human is talking to our voice agent, they don't sort of have that feeling that I'm talking to a machine. So, you gotta like really iterate a lot on sort of the personality you give the voice.
Yep, I also like here want to speak out for burn test as well, because as Sarah mentioning, like we need to do a bunch of the A/B testing in order to collect the real, I mean, in order to support our decision. So it's truly like data-driven position. Where the brain trust is actually the good platform. You can have all of those information all in one place, so you can easily to know what's happening in your production.
Great, thank you. The next question is, does your voice agent have a handoff to human feature? How do you eval when voice could not solve the issue alone, but not escalate to human?
Yeah. I I mean, right now we've not done a handoff to human feature. Like mostly what we do is in many cases what happens is and sort of answers the second part of the question too, is the front desk agent would say, hey, I don't have enough details on this on what you want me to confirm. Maybe you can follow it up in an email. Or one of the things we have to sort of do a lot of handoff to humans related to is when the payment link has to be filled out. So in that case, we haven't received the payment link from the hotel. So what our voice agent is really doing is that, okay, you could not confirm the CCA, but you told me that for this booking, I can sort of go ahead and fill a payment link. So the follow up is that, hey, can you just send me an email to, like cca@navan.com? And at that time, the front desk agent just sends an email, and at that time, the human picks it up as a follow up. Or, for example, if you're not able to resolve the call, like for example, they may say that, hey, I do need a physical card at hand, and this is a VIP that's traveling in. So what we would say is, okay, that's great. Thank you for letting me know about it. And then we let the payment ops team know that they should be following up with the hotel with a call to ensure that the front desk agent knows how to handle the situation. So we've kind of like built a lot of, like, I would say, breakers in the call flow to make sure that the appropriate level of follow up is happening with humans. But we don't have like a real time handoff to a human right now.
Got it. These are some great questions. Keep them coming. The next question is, do you have a limit on the duration or turns of the call?
We have a limit on the duration in total because we don't want to like the people keep talking with agents all the way. So like it's totally blow up our token usage. So we do have a limit on that.
Got it. Last call for any questions. In the meantime, Alfred and Sarava had a quick question. One of the tips that you gave was eval your evals. Can you maybe spend a little time on that? Like, is there any guidance on how you did that at Navan?
Yep. So also it's a time, let me bring up that quick these slides again. So basically the whole point for us is because right now for most of the eval task is completed by the LLM. So that being said, eval itself can also have undeterministic behavior. So we need to make sure like the eval itself is accurate. Otherwise, the whole data loop does not make any sense. So that being said, like we've come up with the whole idea how we can tuning our eval to make sure it always give us the most accurate the answer to make us moving every steps into the ultimate goal. So in order to achieve that on a very high level, like we're just trying to mapping the eval task into some of the traditional classifier problem, and we tuning according to the data-driven and also the data-driven way. So that's the total mental mode behind us. And for also like for here is the simple one summary. So first one is like if it is a very simple eval task, like just to make sure you are always trying to using the deterministic way, such as, I mean, LMS judge is one way, but also you can using like the API checks or using the functional check to make sure it's always give you the most accurate feedback. But for the complex eval task, sometimes like the API or the function may not be the easy way to achieve that. Definitely, there's where the stage for the LMS judge, but keep in mind always to make sure it give you the most accurate results, and try like the techniques such as like the chain of thought, and also like try to verify your eval offline to make sure like you always give you the most accuracy.
Great. The next question is, and this is more for Brain Trust, but Alfred and Sarah, it would be great if you could jump in. How does Brain Trust help you iterate the evaluation system? Can Brain Trust evaluate audio?
Uh,
Yeah, go ahead, Sarah.
so I think like number one, what Brain Trust gives you, so Brain Trust does support multimodal, right? Um, but I think the way you want to think about Brain Trust and what it provides you is like a framework, right? And a process and a centralized place for you to be able to operationalize your evals. Like um unlike, just to compare, with test-driven development, right? Unlike TDD, right, where there's like, mostly you sort of like either you pass or you fail, right? But evals are much more complicated than that, right? It's not just sort of 0, 1, pass, fail, right? You want to, like, if I go to audio, right, you want to be able to evaluate things like, voice tone, like, how well the responsiveness is, things like latency, like things like, like in the case for us where we are building chat systems where there's like tool usage going on, you want to be able to sort of look at that entire flow of things as well. And then, like I said, there are areas where you do want to hand off to humans as well. So like brain trust provides you, all that entire framework for you to be able to run your evals. And also every the entire eval doesn't have to be run within brain trust as such, right? Like what brain trust is your sort of your one stop place for you able to store how your evals are getting conducted and operating in your system. It doesn't have to be like the single stop place which is actually running your eval as such. It can also be a place where you store your evals to be able to sort of have it on record and improve it. Yeah, Alfred, go ahead if you want to add something to that.
Yeah, so 100% with what you say. And also the one thing I want to add is from our experiences, we find out in the AI application, actually the human feedback and user behavior plays a critical role in the success for all of the AI application. Because when we come up with any of the AI apps, it's very easy to say one is good to use or it's not that good to use. But how we measure and observe that is actually become one of the problems. For the traditional software, such as like we are using traditional app, like such as for the API call, we're just measuring if it's like returns 200 or if there's any internal error or 400 error, if there's any metrics. That is the traditional way how we measure the performance for a system. But when coming to the AI world, I mean, performance, I mean, the API success rate is just one thing. We need to make sure the end-to-end is providing the best user experience to the user. But how we collect those feedback end to end is becoming one of the things where the brain trust is actually providing the perfect solution for that. So we can collect starting from the API performance into the all the agent intermediate steps, as well as the human feedback into all in one place, where you can have a high level idea what is your performance for AI apps. So that's I would like to say the value like the brain trust most added to our whole development feedback loop.
Yeah. And I do know that there is a loops feature as well in brain trust. We haven't used it yet. That kind of helps you improve your evals as well. We haven't used it yet, but Mohan, maybe that's a next webinar you can sort of do on loops so that maybe even we can learn from others.
Absolutely. Yeah, we'll have that on the plan. Maybe we'll take one other question. This is a follow-up on the handoff question. To send a payment link, do you require user login before talking to the voice agent, or authentication or email is received by the voice agent? Asking because it's easy to make mistakes getting email address from voice.
Um, So I so okay, there was a few things there. So in terms of the payment link and who sort of processes the payment link, it's not the voice agent that's doing it. All the voice agent is doing is just making sure, or rather, what the eval is doing is making sure that, hey, this was a particular kind of call that required a payment link follow up, right? Um, to facilitate the handoff, the voice agent definitely goes ahead and lets the front desk know that, hey, can you email it to me at this particular email address, right? But once the payment ops team sees that the call has been categorized as something that can be only paid for with a payment link, then regardless of whether an email comes to them or not, they know that the payment has to be done through a payment link, right? So maybe the email was not correctly communicated. Could be. We haven't seen that as such right now. We haven't faced that level of reliability issues. But the big point, the meta point being, is that we've categorized, right, this particular call as something that requires a payment link follow up from our payment ops team, which we are able to do quite reliably and successfully right now with Brain Trust.
Great. We have the last couple of minutes. Are there any other questions? I'm also going to drop in some resources as you explore further. One is a link to a cookbook on voice agents from Brain Trust, and the other is a blog post from Navan on how they built their AI voice agent. Again, quick reminder that we are recording this webinar, and we'll share out the link, the recording, and the resources. The recording will be made available on our Brain Trust YouTube channel. Are there any other final questions? We have a couple of minutes. Also, Sarab and Alfred, what's like the next iteration of this? What's next? What is the team cooking on now that you have kind of released this and you've been able to see how your users are interacting with it? What does the future look like in the next 6 to 12 months?
Yeah, I think like one thing that we've sort of adopted as a company and as a team is building AI for like actual real world use cases, right? Like we really want to like help travelers, help employees with like, having an amazing, travel and expense experience. And everything that we're doing right now in terms of AI is towards sort of like really meeting at where the traveler is, at where the employee is, at where is it that the touch is happening with the travel and expense experience. So there's a lot being cooked, but I would say our overall mission is to build sort of like real world AI use cases where we are actually able to help you. So I would say, sign up for Navan if you're not already a customer. And if you are a customer, like there's some interesting and exciting things coming in the next couple of months that I'm sure you'll be very excited to use.
Awesome. Thank you, Sarab and Alfred. Really appreciate your time. And thank you for walking us through your process of building this, but also taking all the questions. Thank you, everybody who joined us. Lots of great questions and good discussion. As mentioned, we will follow up with the recording, and they'll be made available on the Brain Trust YouTube channel. Keep an eye out. We are going to be doing more webinars, and like Sarab mentioned, maybe one on Loop in the coming weeks. So we will share out those invites with all of you. Thank you, and have a great rest of the day.
Thank you. Bye.
Thank you.